Let's look at OpenStax College Physics, Chapter 17, Problem 18. What is the decibel level of a sound that is twice as intense as a 90 decibel sound? What is the decibel level of a sound that is 1/5 as intense as a 90 decibel sound? So I'm going to write on my knowns and unknowns. I don't need a diagram, but I have here a list of useful equations. So the first equation here is the decibel level. So beta is 10 decibels times log base 10 of the intensity of one sound divided by the reference intensity, the threshold of human hearing. And then some other useful log identities are here. Log A plus log B is log A times B, and log A minus log B is log A over B. So you'll see how we will end up using them, or one of them. So we know that the decibel level of a sound is 90 decibels. So let's call this beta 1. That's 90 decibels. And then we're told that in part A that the intensity of sound 2 is twice the intensity of sound 1. So that's part A. In part B, we're told that the intensity of another sound, let's call it 3, divided by the intensity of sound 1 is 1/5. So what we're looking for is the decibel level of sound 2 and the decibel level of sound 3. We can write the decibel level of sound 1 as using the equation 10 decibel log base 10 I1 divided by I naught. And we can write the decibel level of sound 2 as 10 decibels log I2 over I naught. So the difference in the decibel level will be, I'm going to factor out the 10 decibels, so I have 10 decibels, and then log I2 over I naught minus log I1 over I naught. And then I look at this identity and I see that my A is actually I2 over I naught, my B is I1 over I naught. So that means that I can rewrite this as log A over B. So we'll do just that. And this becomes 10 decibels log I2 over I naught divided by I1 over I naught, which then reduces to 10 decibels log I2 over I1. So we set up our equation. Now we're going to look at part A. So in part A, we know that the ratio of the intensities is 2. So delta beta is 10 decibels log base 10 of 2. And we get about 3 decibels. So since beta 2 minus beta 1 is 3 decibels, that means that beta 2 will be 90 plus 3, or 93 decibels. In part B, we know that, or we solve for delta beta, and that will be 10 decibels log 1/5, and that will be negative 7 decibels. So then beta 3 minus beta 1 is negative 7 decibels, meaning that beta 3 will be 90 minus 7, or 83 decibels.